Thank you. So I'm going to talk a little bit about the NIH perspective. And to give you an idea of where I'm coming from, I direct the Center for Scientific Review, which runs the peer review activities for about 3/4 of the applications that come to NIH. So we bear pretty heavy responsibility for trying to decide on the merit of applications. And that process has come under a lot of pressure recently because of this issue of rigor, transparency, reproducibility that has been of interest throughout the scientific community. We start with a great mission to advance knowledge about the nature and behavior of living systems. And Francis Collins emphasizes that that's a two-part mission, one to develop fundamental knowledge of biological systems, and then the application of that knowledge to enhance health, lengthen life, and reduce illness and disability. Much of our ability to meet the mission is through awarding research grants. This is complicated by the history of funding at NIH, which has been very generous in an important sense. The blue bars here, this starts from 1998 and goes to 2016. The blue bars represent the absolute dollars that NIH received, and the bars in yellow are the representation of those dollars in constant 1998 dollars. You can see that on the one hand, NIH has been a privileged organization in that despite what has gone on with much of the government, with severe cuts in many parts of the civilian sector, NIH has kept on an even keel and even increased over the years. And yet, from the perspective of the scientific community, the loss of dollar value from 2003 to the present, last year we did get the first real increase over inflation that we have seen in the last 13 years. The perception has been of a general scientific recession because of the slow but steady decline in the purchasing power of our budget. This has been complicated further by the ups and downs, but the rather steady increase in the number of applications NIH has received. And when you divide the number of dollars by the number of applications, it means you get this picture of overall success rates. In the year 1979, NIH almost hit 40%, but right now we are in the area of 18%, 19% success rates, which is higher than the actual odds of success of award of any given grant application. But it is this low success rate which is causing a tremendous amount of the problems that are being seen, and I think setting the stage for more pressure on scientists to think about spin, trimming, doing other things to give them both a better chance of success in the grant pursuit, but also in getting the publications that they need to pursue those grants. And so there's been a number of factors providing pressure on scientists that have been making life difficult. Beyond just the raw facts of success rate, it's the publisher perish notion, the idea that one must innovate, revolutionize, disrupt with every project, that only positive results count, that you must pay attention to factors such as journal impact factors, the number of citations you're going to get, whether or not your idea will get institutional recognition, whether or not that's your own personal institution or university, or institutional recognition from other scientists or from NIH. And finally, there's a little factor of supporting your students and being able to support them reasonably so they can get their work done. And if there's any interruption in funding, that can be a pretty disastrous situation. Maybe an embarrassment to you, but it can be a complete career disaster for a student. So there's this a growing challenge within this structure of ensuring rigor and reproducibility of science that has been noted by the research community and beyond in not just several, now many publications. This is across research areas and especially in preclinical research. The lack of reproducibility of results in studies has been especially concerning to industry in that we have heard without data, frankly, from a number of pharmaceutical firms that they simply cannot trust data that's coming from NIH grant applications. NIH grant-funded publications. And they have to redo everything in order to ensure that their results will work and be trusted by the FDA. This was seen as a major, an issue of major importance to NIH, and has led to NIH trying to take action, well, taking action, and changing both its policies, its way of managing grants, its way of managing peer review, all in an effort to provide more support to increase rigor and reproducibility in NIH grant application and grant funds. Now, Larry Tabak, the Deputy Director of NIH, has produced this slide. There are many more papers right now, but this was just the published papers and published comments about the problem of reproducibility of results at NIH. I've been reminded that while there is a sense of crisis around this, that the work to expand knowledge has been on a fantastic track. The number of techniques and our ability to probe nature has really been expanding at an incredible clip. So in a way, we're in the best and worst of times for science. NIH feels that while there needs to be some serious attention paid to this issue, the opportunities remain, and to a large degree, the legislature or Congress is supportive of the idea that this is a problem that can be overcome and that the opportunities for making progress are truly tremendous. So while I want to emphasize that this is something we're doing something about with you, we believe that the opportunities within science remain very strong, and that while some corrective action is important and needs to be taken, the opportunities are there. A few years ago, NIH did say to itself that we have a problem and that needed to be addressed, and that the Center for Scientific Review, among other groups, played a significant role in helping to work with the scientific community to start enforcing higher quality science and public accountability and social responsibility in the conduct of science. NIH, recognizing that the grant application itself is probably not the critical place for determining whether or not a project will be done with high rigor, is recognize that it needed to start actually with the publishers. So NIH leadership convened a large group of the editors and publishers of the top journals, and worked out a general agreement that there would be increased attention to methodology and approach across the board for biomedical research publications. That has gone, we believe, a long way towards helping to correct problems. NIH did not adopt a universal checklist. There were a number of areas in which editors agreed they would tighten things up. But we understood and believe that the problems were slightly different in a number of different areas in different fields of science, and that those fields needed to take responsibility for deciding what needed to be done to have the strongest research. We have been, those of us from NIH who are here, have been very pleased by what we've been hearing here about different ways of improving the output of science, and we strongly support the idea here. But what we have concentrated on within peer review, our scientific premise. We have now recognized that the term premise was probably not thought through well enough, and there's been a lot of misinterpretation of it. By scientific premise, we've meant that the scientific foundation of a project, either based on preliminary results or on prior literature, was very strong. The foundation itself is strong and not built on sand. That the scientist has shown that they can do research with rigor, especially through their prior publications. That there is full consideration of relevant biological variables, especially sex. And then, as a addition, authentication of key biological or chemical resources. So we've asked our reviewers to pay more attention to these issues in the process of working on their applications, recognizing that for a while we would pay a lot more attention to scientific approach and significance, and less attention to innovation in others, while we're asking reviewers to continue to look at that. Instead of 80% of the variance associated with the approach, now it's more like 90%. I'm not going to go over what are some of the problems. You've all been talking about them for 2 days now, and so you can see quickly the same issues. Raising community awareness is a major thing that NIH has been working on, and it is meetings like this that are really playing a key role there. We're asking that individual scientists also play a role, and I've been pleased to hear in the comments and some of the discussions that individual scientists are taking this very seriously, both in stimulating discussions, in increasing transparency, and promoting training, in encouraging sharing, and in publishing refutations and negative results. So we've been doing this in peer review. I'm not going to, anyone who wants to can have these slides. I'm not going to go into this. Anyone who wants to can look them up on the NIH website. But these are the things we're asking reviewers to look at in addition. this is a reminder that premise is not about the hypothesis or the significance, but really about the foundation of the research. And these are slides which we use in training our reviewers to pay attention to these issues. Related issues that I really want to concentrate on are different research fields may have different best practices and reach different conclusions. We're leaving it up to our reviewers to decide what are those best practices. We haven't changed our page limits, even though many people have wanted that. You can just scan the rest. Finally, I just wanted to emphasize that together we share a great mission, that we have an agency filled with scientists, civil service committed to extramural science to fulfill that mission, and we see ourselves in a partnership with the extramural scientific community. We're asking everyone to avoid both the spin and the cynicism that sometimes comes in as we work ourselves out of this situation. Very importantly, we like to remind struggling students that a PhD or an MD with a research background opens many doors. In my 40 years with the government following, I've been in a program or a science administrative position for 30 years, and I've seen many students coming, some of whom have not made it in science careers. Virtually every one of them have done extremely well. This country badly needs individuals trained in science that know how to solve problems. And those individuals have been able to solve their own career problems, gone out, and gotten very good jobs. People who fail to get grants in science or fail to get a tenured position in science do not end up flipping burgers. They end up with amazing careers anywhere from investment banking to science administration. All of them reflect what a pleasure it is to go to work each day and how intellectually engaging their jobs are. So I think without shame, we can ask people to pursue careers here and to work hard to become a scientist. Finally, we are working very hard to try and figure out how we can reduce the number of grant applications that are coming in. Right now, CSR is NIH is dealing with about 80,000 grant applications a year, up a lot. If we could reduce that 25%, that would bring success rates back into a range that we would all like. And every calculation on the number of applications that are needed says that people are putting in excess applications because success rates are so low. If we could restore success rates, if we could reduce grant applications, we could restore success rates, which would further reduce the need for grant applications. So we're working on a number of different ideas for that, but anyone here who has an idea to help us get there, please let me know. That's it. Thank you very much. I appreciate it.